I hope you enjoyed our videos on AP and GP. Now it is the time to make our concepts a bit more robust. So, we'll begin by solving a few interesting problems. Now I encourage you to solve these problems on your own before viewing at this solution. And even if you didn't get the answer, it's okay. I guess these are a bit of a tricky problems or something like that. So, stay tuned and give it a considerable attempt. So, go for it. I'm waiting. Okay, I hope you are back and let's begin. So, I'm going to write 100 as 100 plus 1, and I'm going to write 1001 as 10 to the cube plus 1, 10 cube plus 1, and 10 to the fourth plus 1. I just rewrote this term, and so on up till 10 to the n power plus 1. Now you can see a GP forming, right? 100 is nothing else but 10 squared. So you can see a GP forming within alternative terms. So I can combine these elements and I can write those together. So 10 squared plus 10 cubed plus 10 to the fourth and so on up till 10 to the n power, and I can write the ones, or I can just simply add the ones, right? These ones are repeated n times, so I can write the summation as 1 into n, which is obviously just n. Okay, now we know the formula for the summation of a GP. I'll just remind you in case you haven't if you haven't forgotten. So the formula is a r n minus 1 upon r minus 1. So using this formula, I can substitute a in here as 10 squared. I can substitute r as 10 and n just remains n. So substituting these values, I get 10 squared r to the power, which is 10 to the power n minus 1 upon 10 minus 1, which is just 9, and plus n, this n right here. So a decent problem. The trick here was to split this like that, and that's just it. Let's move on to the next problem. In this problem, we see we have multiple sevens and we have to add these sevens. So you see 7, then 77, then 777, and so on. So let us see how we approach this problem. I again hope that you have given it a considerable attempt. So let's go for it. So I can take a 7 factor out of this. So I'll be left with 1 plus 11 plus 111 plus 1111 and so on. Now what I'm going to do, here is the key catch in this problem. You have to somehow separate this in forms of tens and ones, and the closest thing I can think of right now is 9. 9 can be split into 10 minus 1. So what I'll do is multiply and divide this equation. Actually, I don't have an equation. This expression by 9. So 7 by 9 times 9, and I'm going to distribute the 9 in the bracket. So it will be 9 plus 99 plus 999 and so on. Okay, the 7 by 9 will remain as it is, and you can now convert this 9 into 10 minus 1 and this 99 into 100 minus 1. Similarly with this as 1000 minus 1. Here's what I exactly mean. So this 9 can be written as 10 minus 1, 10 minus 1, then this 99 can be written as 10 squared minus 1 plus 10 to the cube, 10 cube minus 1, and so on up to 10 to the nth power minus 1. Okay, so 7 by 9 times, again a similar pattern like the previous sum, 10 squared, 10 cubed, a GP being formed. So I can straight away write the sum. I'll again write the formula, a raised to r to the nth power minus 1 upon r minus 1. I'll substitute this, and here a is 10. In the previous problem it was 10 squared, and the rest things are the same. So 10, 10 to the power n minus 1 upon 10 minus 1, which is 9 minus n.